Okay, so we are good. We're going to take this first point on the top here, and we're going to find where that image is. Like we've seen before, I've showed you where that image actually is. It would be found, well, somewhere over there behind the mirror. So I'm trying to draw it, but I can't exactly tell where it is, right? So I'm going to use the laws of reflection to find out where the image of this point is behind the mirror. So where it is over here. So the first thing I'm going to do is I'm going to draw an incident ray at any angle to the mirror. So let's just say I'm going to draw one like this. All right? You can pick an angle. It doesn't have to be exact, just any angle. You're going to draw an incident ray. Okay, and then we're going to do the same thing. We're going to find our reflected ray for this incident ray. How does the mirror react when light shines on it? So we're going to do the same steps we did yesterday. At the point of incidence, we have to first find a normal. Should be at the 90-degree mark. So I'm going to take that and draw dotted lines from there. And hopefully you're all following along drawing. So draw along with me, Andrew. Don't have a protractor. Okay. You can listen for the time being, and I'll give you my protractor after. All right? So that's the normal. We have our angle of incidence. We have to mark that angle. So again, put your protractor along the normal and measure this angle of incidence. Okay, so I'm measuring it to be approximately 25 degrees right here, right, going up. It's 25 degrees. So I'm going to write 25. I'm going to turn my protractor around and mark an angle of reflection also of 25 degrees. That's between 25 and 30. I have 25. Again, your angles will be slightly different. They won't necessarily be 25. They might be 30, 50. It doesn't matter. As long as you have the same angle of incidence and same angle of reflection. So I'm going to connect the angle of reflection like so, and this is my reflected ray, and this angle will also be 25. Okay, so this is what light does to my one ray. Okay, very good. Now I'm going to draw another ray. Again, I can pick the angle. I'm just going to draw it over here. Remember, because we said one ray isn't enough to see where the image is formed. I need at least two. If three, the more the better. Right? Because the more gives you a more accurate image. But I need at least two. Because one ray, I don't really see how the image can be drawn from there. Right? So again, point of incidence, I'm going to set my protractor up along the surface of the mirror and draw my normal, which is at 90 degrees. We're going to construct our normal like so. So this is normal. This is also normal. Right? Next, I'm going to measure the angle of incidence by setting my protractor along the normal and measuring that to be, what do you guys think that is? 12, 13? Yeah? I can agree with that. 12 or 13 degrees. Again, it's going to differ for each person, so I'm going to mark that as, we're going to say 13 degrees. So I'm going to turn my protractor around, and I'm going to find my reflected ray, and I can do that because I know the reflected angle will also be 10, 13 degrees right there. Right? So I'm going to draw my reflected ray by joining the 2 points. And this angle of reflection is also 13 degrees. Okay. Now what did we say on the board? The object or image is formed where light rays converge. Look at my 2 reflected rays. There's one reflected ray over here. I'm going to write reflected ray 1. And there's the second reflected ray over here. So I have 2 rays. Where are they going to converge? Are they going to converge anywhere on this side of the paper? Where are they going to converge? Give me a location. Where do you think these rays are going to meet? Converge means, what does converge mean? Get together? Meet? right? Where are they going to intersect? Where are they going to join? Where would that be? Behind the mirror, right? Because we saw images behind the mirror, and this just makes sense because the light rays aren't going to meet because they're moving in opposite directions, right? So we're going to extend these light rays behind the mirror, but we're going to do so with dotted lines, right? Because light is not actually traveling behind the mirror. That's impossible. There's a wall there, right? There's no actual light that's traveling here, right? So I can't draw a straight line because that indicates that light is moving there. I can't do that because light is not moving. So I'm going to extend this ray as well. And where do they meet? They meet right here, right? And this is the image of my point. If this is point number 1, this is the image of point 1. Right? Does that look about right? Is that, do you think, where that point is? That's where the image is formed? Let's just check. All right, we see, do we see the image? We see our arrow right there. So I'm going to put a, how do you think I did? How do you think we did? So that's where the arrow is, and if you remove it, that's where the image is. I think we're fairly close. Right? So that's where my arrow was. You can see the arrow right there. I can't point inside the mirror. There. And that's where my point is too. All right? So now we have found the image. So all this work that we did was to find the image of one point, this point right here, from the mirror. So now we're going to do the exact same thing for this point. So we're going to have 2 incident rays. We're going to draw 2 reflected rays. And then we're going to extend those reflected rays backwards. And we're going to get our image. Yes, Deepinder, you had a question?
Never mind.
Okay. We're going to go one more round together before I leave you to do some of your own work. All right, so we are going to start with an incident ray of any angle, directed anywhere at the mirror. Doesn't matter. You can put one up here if you like. I just don't like things to get too crowded, right? So I'm going to draw one that's far away. Again, I'm going to, at the point of incidence where the light meets the mirror, I have to draw a normal. Right, so that I can measure my angles of incidence and angles of reflection. So normal, here we go. We'll call this point number 2. All right, so now I'm going to measure my angle of incidence, which is going to put my protractor along the normal. I'd say that's about 25 degrees. Then we're in between the 20 and the 30. So therefore, this angle here is 25 degrees. So I'm going to turn my protractor around, set it along the normal, mark 25 degrees, and then draw my reflected ray. This is also 25 degrees. Okay. We have one ray, that's ray number 1 for the second point. We need another ray. And now my screen is getting a bit crowded, right? I could draw a ray perhaps like this somewhere, so that this would be my reflected ray. But we're going to unlock a secret technique, right? And we're going to use a special angle to draw the second ray. Can anybody guess what that special angle is? My secret technique angle. Yeah? Right angle? You want to get a ray at... So remember, what do you mean by right angle to the mirror or to the normal? you're partially right. So I want my angle of incidence to be 0 degrees. All right? Because I think that's the least crowded of all these things. So I'm just going to draw a ray that's straight to the mirror. All right? So again, I'm going to look at my mirror. At point of incidence, I'm going to construct a normal, which is 90 degrees. And we will notice that my incident ray happens to be along the normal, which turns out to be convenient because what is my angle of incidence? So I still have to write that I've done this, so I'm going to write angle of incidence 0 because otherwise people will get confused. By people, I mean me when I'm marking your tests. I will get confused, so please put I equals 0 so that I can see that you've done this work. Is that okay? So now what is my angle of reflection going to be? Yeah? And how would I draw that? I would just draw something straight back at this one. So again, I put an arrow going the other way to show that I've drawn that reflected ray. And I'm going to write R equals 0, or angle R equals 0, and angle I equals 0. Right? Those are angles. Hopefully that's okay. Interesting, I'm doing this sideways. I can't really do it anyway. Okay, so now I have reflected ray number 1 that's over here. Reflected ray number 2 that's over here. Where are they going to meet? Are they going to meet in front of the mirror? No, they're going to meet where? Yes? Yeah? Behind the mirror. So I'm going to extend these rays, but what do I have to remember while extending them? What should I use? I should use dotted lines. And why am I using dotted lines? Because it's not real light. Very good. Dotted extensions. Extensions. And where those two lines meet, which is right here, is my image of point number 2. All right, now I have 2 points, and it's very convenient that I took the end points because now I know exactly how tall my image is, right? And I'm just going to draw my arrow like so. So if I turn this around this way, I can see that my arrow is not exactly straight. It's a bit slanting, right? And this is what happens when humans try and draw things. There's like human error there. My angles might have been off by 1 degree or 2 degrees, and that's causing my slight slant in the arrow. That is fine. This kind of slant is acceptable on a test. On a test, what I'm going to be looking for are clearly shown angles that you've measured, arrows going the right direction, right? So again, angles that I've written down that I've measured, arrows going the right direction, and dotted lines behind the mirror. If I see a straight line behind the mirror, that's going to be very bad for you. For your grade at least. All right, so this kind of little bit of deviation is fine. This is still, so if you look at this, this is like what a full marks would look like for this kind of question. All right. If I see an image that looks like this is wrong. Okay, I can't see this much deviation. That means you measured an angle wrong and you probably have to redraw it. But something like this or slightly more slanting is fine. I'll accept that, as long as you've written proper angles and show me that you've done the work. Does that make sense to everybody? Are we good? Do you think you guys can try number 2 and 3? Right, I'll give you about 10 minutes to try 2, and then we're going to take up some of these questions on the back. And these are, I think some of them, like question 1 and 4 are the same questions. They're not too difficult. You can answer them right now, actually, if you want to. But we'll take them up. It should take us 5 minutes at the end. So I'm going to give back, carry on your work. If you don't have a protractor, hopefully somebody can share with you. But, all right. So this is going to be one of our learning goals at the end. I can draw ray diagrams for a plane mirror and find the image of a plane mirror? How many are okay with that right now as it stands? Okay? I mean, we'll be practicing this a lot. If you go to page number 4, there's a lot more practice, right? But this is how we do it. Okie dokie. I'm gonna just pause my recording here. Okay, how does the size of objects compare to the size of images? Yes? They are equal or same size. And this makes sense. This is what we see in a plane mirror, right? We're not magnified or smaller. We're the same size, or image is the same size. We talked about this yesterday as well. How does the distance from the object to the mirror compare to the distance from the image to the mirror? Yes? Same distance. The mirror is halfway in between the object and its image. Right? And we saw that yesterday as well. And we can, if we measure these distances from here to here and from here to here, they will be the same distance. Or they should be if all the angles were correct. Third question, why must you find images of at least 2 points on an object in order to locate an image on a plane mirror? Yes, Syed?
Because you need to connect the 2 points to make the image like mine.
Yes? You have anything to add, Madeline?
So that the rays can intersect.
Yes. I'm going to modify both the answer. Both of them were correct. Rays need to intersect because we have noted that the object or image is formed where light rays converge or appear to converge, right? I say appear to converge because dotted lines are not actually converging because they're not really there. They're just appearing to converge at that point, right? But the word converge itself means you need two of something to meet together. They need to intersect. If you just have one, it's not going to converge with anything, right? So you need at least 2. You can draw more if you like, right? But nobody does. I don't know why. Just nobody decides to draw a third ray. It always confuses me. But when you look in the mirror, if your image is bigger, okay, this should be an is. I apologize. Now the question makes more sense. And this is basically the same as question 1. Is your image bigger, smaller, or the same size as you? I'm taking that to mean, yes? Same size? Okay. I'm going to take that silence to mean everybody is looking at me because it's a silly question, because we've done it before, and not because you don't know the answer. So it's the same size image. Are we good? Okay, you have homework. If you haven't completed it already, there's a page 4 and all of this. Sorry. Yes. Super quickly, I will point out that the triangle over here needs 3 points. So you have to get an image of this point, image of this point, and image of this point. So you have to draw 6 rays in total. You have to draw like 1, 2, 1, 2, 1, 2. And that will give you 6 rays to form the exact image of this triangle. Please hand your protractors on the way out. Do you want to keep it?